Okay, in algebra and in Calc 1 and Calc 2, a function is a rule which takes each input, a real number, and specifies an output, a real number. So each real number as input produces a real number as output. We've seen a vector function. That's a rule which takes each input, a real number, and produces an output, which will be a vector. And that vector is essentially or effectively two or three real numbers. If you studied functions from a true mathematical perspective, there is a more complete definition of function, though we will not be using that in this class. Let's talk about functions in the sense of algebra, calc, like functions as in like from algebra, calc 1 and calc 2. How can we describe these functions? There's several different ways that we can describe functions. There's the expression version, that a formula like f of x equals x minus 1 quantity squared. There's a graph that we can draw, and that graph will pass the vertical line test. So here's the example of f of x equals x minus 1 quantity squared. But this graph is two-dimensional. Um, this 2 coming from 1 plus 1, because the input x-axis, that's one dimension, and then the output y-axis, that's one dimension. Okay, one input, one output. Another way you can describe a function would be using a table of values. So I tried to still do the same thing with this function. Here's a third description, right? So we have the expression or formula-based way. We have a graph or picture-based way. And we have this table of values, right? This also describes f of x equals x minus 1 quantity squared. Now here's a new way to describe functions, and this thing is called level sets. And this is going to be a little bit peculiar to do in this situation, but we'll see why we want to do this a little later. So though this was never introduced in Calc 1, or an algebra class, it could have been. It wasn't so necessary then, but we'll see why this is going to be useful here. So what do we do is this. We'll describe the same function, f of x equals x minus 1 quantity squared, using this fourth new description called a level set. So what you do is this. You pick a number k that's in the output, in the range, okay? And then the level set corresponding to this specific output k is a drawing of the inputs which have output k. So for instance, k equals 1. So which x values have output 1? Well, when you plug in x equals 0, you have 0 minus 1 quantity squared, so negative 1 quantity squared, which will be 1. Okay. If you plug in x equals 2, 2 minus 1 quantity squared will give you 1 as well, right? So why this picture? So x equals 0 and x equals 2 are the only inputs which lead to output 1. Now, for output 4, the only inputs are x equals negative 1 as well as x equals 3. And for the output 0, the only way you get the output to be 0 is if you use the input 1. So for each output, there's a separate level set drawing. Just going back, when the output is 1, the only inputs you would get there would be 0 and 2. When you're talking about the output 4, the only inputs that lead to that are negative 3 and x equals negative 1 and x equals 3. For the output 0, the only inputs that will get you there would be x equals 1. Okay, for each output, there's a separate level set drawing. By the way, each level set drawing is drawn in one-dimensional space. Notice how there's these three separate, real number lines. It's just one-dimensional picture instead of a two-dimensional picture. Interactive question. Describe the level set of this function for the output k equals 25. Okay, suppose that f is a function and that the level set for output 5 looks like this. So there's a dot at x equals negative 4, there's a dot at x equals negative 2, and then the interval from 1 through 4, all of that is filled in. So then draw as much of the graph of f as you can. Well, we know that the output is 5 when the input is negative 4, when the input is negative 2, and that the output is 5 for all x values between 1 and 4. And then besides what's drawn in blue, no other part of the graph should have output 5, because this drawing up here is supposed to show all of the inputs which lead to output 5. So the rest of the graph could look something like this. You'll notice what's drawn here in tan or in brown it could be the function f we're talking about. There's many other choices. This is not the only correct answer, but um, you'll notice that the only parts of the graph of this brown graph where the y value is 5 are literally the parts that are shown in blue from above that have just been copy pasted. This depiction on the number line in the question has been raised up 5 units, and you'll notice even after this sharp turn, it looked like we were going to create a point where the y coordinate was going to be 5, so we intentionally did not include that point with that unfilled hole there. Okay, so this is shown in brown as one possibility for the graph of a function, which would fit the bill for the level set for output 5 being what's shown in blue above. Okay, in a nutshell, given a function, the level set for output k is really just a drawing of which inputs lead to that output, right? This is a visual picture of which inputs have output k. If you've taken a class on mathematical proof, the following will apply and perhaps be helpful. If not, don't worry about it. But the level set for the output k, it's really just a picture of the preimage. So for a specific function f, the preimage of this output k, it's the set of all inputs x, where when you apply f to that x, you get k. If this doesn't make sense, you haven't looked at a class on mathematical proof, don't worry about it. You can just ignore what's in this blue box.